Hello, good morning, good afternoon, good evening. Welcome to our workshop on the third day of JuliaCon, where today we will talk about creating simple games with GameZero.jl, which is a package that we created about a year and a half ago uh, to help create and teach programming to young people to create very simple games to just have fun with programming using Julia. We love using Julia for more serious stuff, but this package hopefully will show you that Julia can be used for many more applications than you would think. You don't always have to do sparse metric calculations to make good use of Julia. So for the session today, we will start with a brief presentation that somewhat sets the screen, somewhat sets the stage, and gives you a basic idea of what this package is all about. Uh, and then for most of the next couple of hours, we will go through some example games. We will essentially live code. I will, talk about what I want to do and take you through step by step, creating very simple games from scratch. With me today is Ahan, who has helped creating this package with me and has created many games that you can see on his Game Zero examples repository. Ahan will take us through the presentation to begin with, and then I will, as I said, take us through the uh, through some example games. We will start with just the APIs, and then build a few games from scratch. So that's the plan for today. Thank you for joining, and hope we have fun. Um, So, Ahan, I will let you take it away.
Yeah, if you could switch to the next slide. Right, so GameZero is, as Alex said, a package designed for, kind of demonstrating simple development in Julia, it was designed primarily for beginners. It was made to teach like children or people who haven't been coding for long, to teach them Julia as a way to expand the user base of the language. It is based quite heavily on PyGameZero, which is a great example of what can be done with a package like this. And as a dependency, it uses SDL, which is a very well-known game engine and package which has been used to develop countless AAA games. Next slide. Thank you. Right, so there's been a lot of design which has gone into the package to help reduce overhead in development. So we have a very simple API. There's not a huge amount that needs to be done on the user's end. Like the event loop is defined behind the scenes. All the user needs to do is create two functions called update and draw, which you'll see in a few slides. Window management is just defined by two variables at the beginning of the screen called width, at the beginning of the code called width and height. Actors, which are what we call, which is what objects in GameZero are called. You just pop an image file in the directory and you can just simply create them and give them a starting position. And music and sound files, playing them is as simple as a function. There's no more that needs to happen. So here you see the directory structure. So images for actors, music, which is what loops in the background if you want something like that, and sound effects. And then at the bottom there is your code file. one of them. Well, there is only one. So the event loops, most of it is handled behind the scenes, but of course you will need to write some code. So all you need to do is the draw. So when you want to draw an actor, you put it in you call the method draw on it inside a function called draw, which takes the game as an object. And to increment, say, position or check for collisions, you do that in the update function. Both of these run every game tick, so just as fast as your computer can handle it. And yeah, so movement of actors is handled, well, these dy and dx are given as example variable names, but they're just basically velocity, how much you increment their position each time you add it, or you add it to its position in a game. Right, so keyboard inputs, also very simple. You just check the keyboard object from the game, and in the on key down function, which takes the game and the key as an object in it. And so for timer-based tasks, obviously you can't use sleep in the foreground, otherwise it'll just, stop the whole game. So we use a function schedule once, which takes the function you want to call and the number of seconds you want to call it after. So that's all I had. I'll go answer questions if anyone has any.
Cool, thanks, Ahan. So that very brief presentation hopefully gave you a sense of what GameZero can do. And you saw the API is really, really simple. There are just a couple of functions that you need to write, and the game is essentially made for you. So, so this sets the stage, hopefully, but of course we will, see how to use this. We will take it step by step and see how can write a game pretty much from scratch, right? Questions, if you have, go to Pigeonhole. The URL is at the bottom of the screen. That's where we are looking at questions. It's difficult to keep track of questions on the YouTube chat. So, that's, please don't ask questions directly there. We may not see it. We'll miss it as it flows past. So if you go to Pigeonhole, the URL again at the bottom of the screen, we will be able to see and manage those questions easier. There are a few people having trouble compiling GameZero. I'm not really sure what's happening because I don't know what the error is, but we will maybe talk about it. Maybe at a break, we can work through people who are having issues installing and compiling it. All right. Okay. To start with, I hope people can see my screen. Maybe I will increase the size a little bit, and that may help. Right. So I will do all my coding in VS Code, which is what I use for all my development. In VS Code, I have the REPL at the bottom of the screen, which is where I will execute the code that I write, and I will write the code in the VS Code edit window, right? So I have a Julia REPL open. As you can see, I am currently in this directory called GZ Workshop. And in this directory, this is where I will write all the code that we do today, right? So to start, let me add a new file. So let's create a file called basic. right? Or let's say, let me call it my first game.jl, right? So this is the start of a game, right? We start a game by creating a file, of course. You don't have to worry about creating a package, having it in source. The whole Julia package structure is not needed for creating your first game, right? And so we can just forget about it for the first instance. What you do need to do is create a Julia environment. So for those of you who are not familiar with Julia, Julia's package manager creates an environment in a directory, and in the directory there's a file called project toml that defines that environment, right? Again, you don't have to worry about the file itself. What you need to do is go to the package REPL in Julia, and you activate an environment. This can be any directory that you want. So I currently activate the current directory that I am, which is activate dot. So that activates my current directory, and that's the directory in which all my packages metadata will be stored, right? Now in this environment that I have just activated, I will add packages, right? So I will add GameZero. So the first package that you need to add is GameZero, and that will, update the registry, download GameZero, download all the dependencies that GameZero has, such as SDL, and it will, download the binaries depending on your operating system. So if you're on Mac or Windows or Linux, the correct versions of SDL will be downloaded, because SDL, as you know, is a C library, and so it needs to be compiled, but you don't have to worry about compiling it, right? So someone complained that the screen is a bit blurry, so I increased the size. Hopefully that makes things a little better. But again, let me know if there are any issues. There's a question about which IDE I'm using. I am using VS Code, Visual Studio Code, which is a free IDE which you can download, and that has a very good support for Julia. And so that's the IDE that that I'm using. Someone asked, you get syntax space before dot. Activate is a package command, not a Julia function. So you need to press the right arrow key to go to the package mode in your REPL before you can use the activate command, right? And then you will get the correct result. So press right square brackets, which is the right square bracket key on your keyboard, and that will get you the correct result. Okay, right. So my packages are still installing. There's a question about is it straightforward to produce games that can be run on any system without a Julia installation? That is possible, but not very straightforward yet. In Julia, there is a thing called package compiler. If you search for package compiler Julia, you will find documentation around how to use it, and that's what you would typically use to compile the Julia, your game with Julia itself and all the dependencies. Package compiler can help you do that, right? So that's what you would use. As I said, it's not very straightforward, but it is certainly possible to do that. Okay, right. So that's adding GameZero. and that's what this would do. I will, you can say in the package REPL again, if you press square bracket, right square bracket, you can say status to see what is the current status. And other than GameZero, I also have the colors package installed. So you will say add colors, and that will install colors as well. Right? So these are the two packages that you will need to run everything that we will do today. Okay, so that's by way of background. So this sets your environment up so that you can use GameZero and start writing code. Right now, the code that you write, this is my first game. That is the code that we will write. To run this, the first thing that we will do is load GameZero. So I will say using GameZero on my REPL, that will load the package, precompile it, and I think that is where some people are having some problem. But as I said, we will try and debug it during a break. So using GameZero will load GameZero into your environment, into your REPL, and then you can then call the run game function and give it the name of the file, right? So you say my first game kill, and that will basically run this game for you, right? Now, before we do that, let's write a few lines of code. So when you write your first game, you need to define the window that that game will create, right? So you can say to give that window, you have to give the size of the window. So you can say height equals 400, and let's say width equals 400, right? So these are magic variables. You just define them, and that will define the size of your function, size of the window that you create, right? And then you need a draw function, right? The draw function, as Ahan said, is the sort of entry point to actually rendering your game on code, on screen, right? So we will start by defining a draw function, and we define a draw function, maybe an empty draw function to start with, and is just an empty function that does nothing, right? And that's all that we will start with. So a draw function, a height, and a width. And we say run game, my first game, and let's see what happens. Give me an error, right? Let's try and see what, okay. So the draw function needs a game object, because the draw function, you need to give your draw function some information about the game that it is running. So the draw function will need to be defined with a game object as the input that it takes, right? So let's try and run this game now, and that still fails. So let's see what's happening. Okay, this should work. Let's run some existing game. Let me restart my REPL and see if Sorry about that. I'm just restarting my environment. Hopefully that will help. Function draw. Just do that. Okay. Right. Okay. So this is what this game draws, right? So the minimum that you need to define a game is a height and a width of the window that you are creating, and two functions, draw and update, right? And that gives you an empty game, right? So, yeah, actually, you don't necessarily need a parameter to draw. You know, sometimes you want the game object information, and so you can give it a parameter game, but it's not necessary. So you can just say you need a draw function and an update function, and that's all, right? And that's the game that is created. Okay, so you exit the game by just closing it, and that will get you back to your REPL, and then we can carry on, right? So the next thing that you want to do is, you know, the background is white. We want to change it to something slightly nicer, and we say background. You can give it a background. The background is the another magic keyword that defines um, that defines you know, what the background of your window is, right? Now this colorant keyword here is something that comes out of the colors package that we defined before, right? So you know, I can say using colors, and then let's say colorant red, right? And this is a way of defining a color. So this, if you see colorant red, it opens up the plot pane in my VS Code, and it shows that, you know, this is the red color. And if I say colorant white, that's the color. I can even probably say colorant, let's say 456, or maybe 44556. Let's see. That works. That does work. That gives you a gray. You can give, you know, hexadecimal colors like you would do for a CSS or HTML, and that works. So in GameZero, we use the colors package to create colors, and that is what we will use. So we say background color in purple, and that defines the background, right? So let's see on my game, and okay, that's still white because I didn't save it. Let me save it, and now my background is purple, right? So now, once I have the background, I need some images to actually draw some object, right? There are various ways of drawing objects. First, let's try to draw an image as an object. And as Ahan said, the way you do it in GameZero is the concept of an actor. You need to create an actor, right, based on an image. So the first thing that you do when you you know, create a game and you want images to it is the directory structure in which you store these artifacts, right? These game artifacts. In GameZero, you store these artifacts as directories within your game directory itself. So where your jail file lives, subdirectories within that directory is where you would store artifacts. So for images, you would store it in a directory called images. So you would create inside BZ Workshop, which is where I have my first game.jl. I would create images. And in this image is directory, I would store the images that I need, right? So let's take this image. I will store an image here called, I will copy it from my machine, and that will go inside images, and that's an image called alien, right? So this is the image that you can see on my screen. Now in my first game, I will create an actor. So I will say actor is alien.png. And then inside my draw function, I will say draw the actor A, right? So A is just the name of that actor. I can say, I can call it anything, alien, let's say, I'll call it alien actor, and I say draw alien actor. And let's save. And that's my actor, right? So that's drawn my image. You know, this image here that we saw is now being rendered inside my game. Okay, so let's close that. It's at the left-hand side of the screen. Now, by default, okay, let me actually get this back in. The actor is drawn on position 0, 0, right? Because that's the default size. So this relates to sort of two concepts that are important to understand. One is that the game coordinates in GameZero start from the top left corner of your game window, right? So the top left corner is 0, 0, and then X is horizontal and Y is vertical, right? So this position here where my cursor currently is 0, 0, and then X is this direction and Y is this direction, right? And so those are the coordinates. That's the coordinate scheme that we will use for all the games that we will draw, that we will write. So this image, this actor is drawn on 0, 0. And the second concept, therefore, is that the default position for an actor is the top left of the actor itself. So the 0, 0 of the game screen and the 0, 0 of the is the 0, 0 of the actor's top left. And so therefore, the actor itself is positioned on its top left, touching the top left of the screen, right? Now, we obviously want to change it. So we want to, move the actor a little bit to the right and down. And so the way we do it is by, there are various ways to do it, right? And, you can look at the documentation to see the different ways you can set the position. But the way we will do it is probably one of the simplest, but we will see other ways as we go along. So we will say alien.pause, which is the keyword for a position, and we will say this is 120, comma, let's say 180. 180. Okay. So we say alien actor is the variable that I use. Alien.pause, alien actor, and that's where we draw this, right? So you can expect what will happen is my alien has now moved to this position sort of slightly below center of the screen, right? Make sense? Now, the whole point of a game is to move things, right? If everything is static, it's no fun. Although we will actually develop a game which is completely static in a bit, but most games will want to move things around. So the way you move things is basically changing the position of the actors itself, right? So let's say in my update function, I say alien actor dot x is equal to alien actor dot x plus 2. Right? What happens? And there my actor starts moving, right? I can change that to alien actor dot y is alien actor dot y plus 1, and then my actor starts moving diagonally, right? And as it exits, it just goes down and out, and there it's back. It doesn't come back because we haven't asked it to come back, right? So, but hopefully, these 2 or 3 little concepts give you a flavor of what you can do to create games, right? So the first idea is that you create actors using images, right? You can then change the positions of those actors either in the beginning or in an update function, right? So the update function runs every frame, as Ahan said before, and the update function is where you change the positions of your actors, and that allows you to draw things in different places, right? And then every frame, the update changes the state of the game, and draw runs every frame, and that actually draws the images themselves, right? And so update and draw, update and draw, update and draw, 60 times a second is basically your game, right? That's the key sort of concept for the game, right? Make sense, hopefully. So that's really all that there is to it, and and everything else is just a matter of detail, right? You need to check where your actor is. If it hits the end, you need to get it back. So you write loops, and but that's just details in some sense, and we will see some of that as we go along, right? Okay. So that's a basic game, right? Or a basic screen, as it were, right? The next thing that you want to do is probably draw text, right? Now in SDL, typically, and one of the things that SDL does is ask you to provide the font that you use to draw, right? So one of the things that you have to do if you want to draw text is create a font or specify your font file, right? And you can find the font files on your machine. So if you're on Windows, they'll be inside some Windows directory, Windows fonts directory. In Linux, they'll be in some user local fonts directory. And that makes it difficult to write games that are cross-platform. So what we will do usually in GameZero is specify the fonts along with your game. So like you have the images directory, we will create a directory called fonts, right? So, just here in my GZ workshop directory where I am, I will create a folder called fonts, and in that fonts directory, I will drag a font file, right? So that's a font file which is called moonhouse.ttf. This is, it's a sort of slightly funny looking font that is good for games that I downloaded from the internet. Good fonts are paid, so you can, pay for a font and have it as part of your game, right? So in my fonts directory, I create this Moonhouse font, right? Now, once I have this font, I need to then display it. And the way we display it in GameZero is to create a text actor object. So, so we have my alien actor. I then create my text actor, which is instead of the object actor, I create the object text actor, and that is instantiated with some text and some font. So let me say hello JuliaCon and the font name, which is Moonhouse, and then GameZero will look for the font and load it, right? Now, like any other actor, you can say text actor dot pause equals let's say 120, right? And that's all that you need to do. So these two lines basically give you the text. And when I run the game, my text is not showing. Why? Okay, why is my text not showing? Because while I have created the actor, I haven't drawn it, right? So I say draw text actor and save, run, and there's my text, right? Now, the text actor is also also an actor. So let me see if I can do that. I can probably say text actor equals text actor.y plus 1, and let's see if that works. Yep. So now my image actor is moving diagonally and my text is moving down, right? Hopefully that all makes sense. That is, the simplest way to create images and text on screen, and then you can play around with it, of course, right? Now, then the other thing that you sometimes need to do is draw geometric objects, right? So you want to draw circles, images, texts, and you want to then draw those objects using this. Now, the way you do that in GameZero is again pretty simple. You create a line object or a rect object or a circle object. So I can create a line. Say I can create a line called L, and that's and this defines the geometric positions of the line, right? So a line is defined by x1, y1, x2, y2, which is the starting point and the ending point, right? A rectangle is defined by similar, the two corners. So a rect is defined by a rect. Actually, let me maybe do that. Right? And a circle is defined similarly by, its radius and the x, right? So radius and the x1, y1. So the position and the radius. So x1, y1, radius, x1, y1, x2, y2, right? So, right? And that's how you create these objects. And then you have to draw them. And when you draw these objects, So when you draw the line, for example, you say what colorant you want this line drawn. So I want to draw this line as yellow. I draw the circle. I want the circle to be white. And I want to draw the rect as colorant. What color should I use? Let's say black. Right? So you create these objects, which are just the geometric objects, and when you draw them, you specify the color that you draw them with. Right? There. So you have the circle, which is in white. It's the line in yellow, and the rectangle, which in black, but it's quite faint. So maybe you have to maybe squint a bit to see it. Right? Now, these objects are slightly difficult to see. So what do we want to do? We will probably want to fill them, right? So the way we do that is to say yellow. So draw the circle, and we say fill equals true, and the rectangle, say fill equals true, and that's it, really. And my circle is drawn, my line is drawn, and my rectangle is drawn as well. And now my circle and lines are filled, right? And that works. And again, these objects, you can change their positions as well. And, so we can, let's try that, if that works. Again, live coding, so maybe not, who knows. In my update function, I will say line dot y equals line dot y plus 1. Let's see if that works. No, that doesn't work. You have to change the line itself, right? So the way you do that so you can't, so the line is not an actor, but what you would do is, the way you would do it is in your draw function itself, you would, let's say, create line. And so this is 50, and we would say 50 plus I. Right, and 350 plus I. Right, and you would say global I equals 0. And then in your update function, you would say global I equals I plus 1. Right? Hopefully that makes sense. And there you can see my line is moving to the right very slowly. I can make the line move horizontally by changing the y-axis, y dimension. Let's see if that works. And there, my line is moving along with my text down my screen. Okay. Okay. Cool. So I think that sort of completes a quick overview of the API of GameZero. I want to take a 5-minute break, and then when we come back, we will start with a more realistic game. we will sort of define the game and then develop it from scratch, right? So we'll take a 5-minute break. If you joined, in the middle of the workshop, I would suggest you rewind on YouTube and listen to it, because what I'm doing is mainly live coding. And once this workshop is done, all the code that I'm writing, I will upload it into into repository, on my GitHub. But for the moment, since I'm live coding, it is most useful if you rewind and start, right? So with that, let's take a few minutes break, and I will be back in 5 minutes, and then we will, develop a more realistic game that should hopefully be a little more fun. In the meanwhile, if you have questions, keep them coming on Pigeonhole, and I will answer them as I see them. Okay, back. Hmm. Hmm. Right. Okay. We are back. Hopefully, you're enjoying this session. Once again, keep the questions coming. It seems GameZero doesn't work on the Mac. SDL apparently is having problems on the Mac. I don't know why. I haven't used Mac in a while. Somebody with the Mac might want to debug that. I think the artifacts are not correctly formed on Mac from what I can see. So if you're on the Mac, apologies. Hopefully, this recording will be available for you later once we fix it. But if you're on Windows, I am on Windows, and it does work. If you're on Linux, it should work as well. The one thing that doesn't work on Linux is unfortunately sound, because again, there's a problem with compiling SDL with sound on Linux. So right now, Windows is probably your best bet. But you should be able to, play the games in Linux easily. Right. Okay. So that was, I think, the main question that's outstanding. But if there aren't anything else, then let's get started. Right. So the game I want to do next, we will do two games in the next session. So we'll do one game, take another break, and then come back and do a second game, right? So the game that I want to do, let me show you what I want to do as a picture. What I really want to do is something like this, right? So I want to create a Christmas-themed hangman game, right? So you have a hangman game where most of you would have played it when you were kids, where you have to guess a word, right? So either the computer chooses a word, or your friend chooses a word, and then you have to guess the word by guessing each letter, and then you have to guess it in a certain number of tries, and you document the tries by drawing a picture of a hangman, and then once the hangman is complete, you lose the game, or if you guess all the words before the hangman is complete, you win the game, right? So I want to do that, and that's, I think, a simple enough game that will give you a sense of what Julia can do, what GameZero can do. But instead of drawing a hangman, I want to draw a Christmas tree, right? So I want to draw this shape, and we can then play it at Christmas during our Christmas parties, right? And it's July, but come on, Christmas comes in July these days, right? According to all the retailers. Right, so that's the idea, and I think GameZero will allow us to create this game in less than 50 lines of code. I think we will probably get it done in 20-30 lines of code, right? So so that's what we will do, right? Okay. So let's get started. Instead of my first game, I want to create a new file. What shall we call it? Let's call it Christmas.jl. Right? So .jl, that's my file. Again, I start with height. So let's say 600 by 500 is a decent option. And then I want my background to be a nice Christmassy color, right? So I Googled for a nice Christmassy color, and let's see what I found. this seemed like a nice Christmassy color, right? So a nice red from Father Christmas's coat, and that's what we will use. So we will say background equals coloring, right? And then let's get our draw function. Right. Let's see. And we want an update function, I suppose. Or maybe let's just start with the draw function to begin with. My first game, instead of my first game, I say, yeah. And there you go. That's my nice Christmassy background. And that's the beginning of my game, right? Now, I want to draw this picture here, right? So this Christmas tree, which, as you can see, is just a set of straight lines. That's all that it is, right? And all we want are these sets of coordinates, right? So the coordinates of these corners. So this coordinate here, this coordinate here, this coordinate here. Or in other words, all we want are the coordinates of each of these lines. So this line, this line. So there are about, maybe about 10 to 15 lines, I think, that define this Christmas tree, right? And you can take a chart paper, a graph paper, and plot these, and that would be pretty simple. But an easier thing would be to ask Google. If you search Google for, Christmas tree coordinates, you will get many pages that will give you that result, right? So, Google is your friend. That'll give you the set of coordinates, and I will, I did that before, and I just copy pasted that right here. Right? So my screen is my fonts are a bit too large for this lines, but hopefully you can see. So my tree lines is an array, and each array is basically a set of tuples. Each tuple is a tuple which is a coordinate itself, right? So each of these is a line. So a line from 340, 300 to 340, 260. That's one line, right? The second line is from 340, 260 to 500, 260, right? The third line is from 500, 260 to 340, 150. Again, remember, these coordinates are in the pixels in the screen that you draw. And these are pixel sizes, and they start from the top left corner always, right? So all our coordinates always start from the top left corner, right? So these are the coordinates that I have, and then I want to draw them, right? So what do I do to draw them? I can just draw these as lines. So let me type that inside my function draw. And I'll spend some time explaining this code because this is getting to be slightly more complex Julia code than you're used to. And I will break up this into multiple lines because my screen is too small. Right, so I have a loop from 1 to 15 because I have 15 lines here, right? So this is line 1, this is line 2, this is line 3. So I have a loop from 1 to 15. In each element of that loop, I draw something. And what do I draw? I draw a line. Now, line, remember, takes 4 coordinates, right? x1, y1, x2, y2. And those are the first tuple and the second tuple. So I say tree lines, which is my array of coordinates. My tree lines, I, which is 1 to 15. And then the first element will be this tuple. And then I have this ... which is a Julia concept called destructor or a splatter, and what it does, it takes this tuple and takes the individual elements. So this, for the last line 15, this will actually be something like draw lines, and then we want 260, 300, 340, 300, right? And then a color called tree green. So this is the line that I want, and this is basically what these splatters, the splatters basically take this structure here and splat them into this element here, right? Okay, so that's what we want. And then we want tree green, which is a Christmassy green. And so let's see what we can get. So I have a colorant here, which again I asked Google for what is a good green, and that is this nice Christmassy green, right? So I can say this is my tree green, right? Close that, go back up, and say tree green equals colorant of that, right? Okay. So that's the green color that we want, and this is the Christmassy red that we want. Okay. Now let's see if that works. Save it and run my Christmas game, and there we are, right? So that's my Christmas tree drawn, and you can see it's just drawn this Christmas tree, right, in one go. So that's useful, but I probably don't want to draw it like that. But let's talk about the game logic itself now, right? So I want a hangman game, which means I want a word list. So let me get a word list from my hard disk. Again, Google for word list, you will get a word list. You will notice that I love Google. Well, the service, not the company, let's say. So let me see on my downloads folder. I will have a word list somewhere. I will no, not here. Sorry, give me a second to search my hard disk. Yeah. So there's my word.txt, which I can copy, and there is this word list, right? Words.txt, and this internet tells me is a word list of very hard words. Okay, bandwagon. I mean, come on, can anybody guess that? But it's a good list to play for, right? So that's my word list, and then I need to load that into our game. So go back to my source, and then at the top, right? So let me start writing code here, right? So the first thing that we do is we read the word list. So read lines is a Julia-based library function that reads files. Join path is something that joins a directory and a path. Add_dir is a Julia-based library macro that basically tells you what current directory your file is in. So this ensures that even if you are running this code from some other directory, so long as words.txt is in the same directory as your JL file, it'll read it, and then words.txt is the file that you read, right? And I can show you what this reads. So word list will I can actually run it in my REPL, just word list equals defines words.txt. Here I don't do the add this stuff because I know I'm in the current directory, and that gives me the word list, which is a 213 element vector, right? So word list is a vector of string elements, and I can say length of word list, and that's 213. Now an array or a vector in Julia can be indexed by square brackets. So I can say word list 1, which is the first element of word list. I can say word list 200, which is the 200th element of word list. Now we'll notice that the words that it gives, it has some padding in the beginning, which I probably need to clean up, right? So the way I clean it up is I write some code like this. So I can say word list equals strip dot word list. Okay. Now, strip is a Julia base library function that basically removes white spaces from a word, at the beginning or the end. The dot basically is again a Julia function, a Julia feature that takes a function and applies it to an array or to any kind of iterable object, right? So word list is an array. Strip normally applies to a single string, but we want to apply strip to every element in word list, and the dot basically does that. So if I run this code in my REPL, right, it will give me a new word list that is still a 213 element vector. And then when I say word list 200, you see it has removed the elements from the empty spaces from beginning, right? So that's my word list. And then I need to choose a word that is simple. I can say word equals rand of word list, right? That will select a random word. Now, after that, I need to know how many characters I have, right? So I say num cards is length of word. That will give me the length of a word. So again, if I run this on my REPL, you can see num cards will be 7. So the word that it chose is buzzard, and num cards for that was 7. Okay, so now when I'm creating a hangman's game, I need to operate on each element of the word one by one, right? Because the player will select each letter one by one. So the way I will do that is I will have an array of answers, which is what the users will guess, right? Or guesses. You can call it guesses or answers. And I initialize that with spaces. So I say fill space, and then how many spaces do I want? I want num cards, right? And so when I execute that, I say what happens. Sorry, that. Okay, so answers is now a 7 element vector. Why 7? Because my word had 7 letters, right? Now, when I'm playing, I also need to store the list of all possible letters, right? So let's do that. So I say letters is, so all the letters in Julia is, let's say, A to Z, right? So these are all the characters A to Z. So single character, single quote strings in Julia are actually characters. You can't do ABC with single quotes. That'll have to be a string, but A is just a character, right? And so A to Z is the list of all characters between A to Z. And then I have something called collect, which will take that A to Z iterable and actually create an array. So let me show you how that works. Again, A to Z. Right? That just gives me, starting with A, one character each, and ending with Z. Right? And then if I collect that, now in this workshop, I'm assuming that many of you are new to Julia, and so I'm sort of explaining a lot of the Julia features in a little bit of detail. So if you already know Julia, then have a coffee while that's happening. But hopefully this is useful to a wide audience that we have today. So collect will basically take that iterator A to Z and create an array or a vector with cars. And then I want to convert this to strings, right? Because I actually want to just work with strings. And so there's a function called string that takes a character and creates a string. And I apply that to the entire array. So I have a dot, which is in Julia called broadcasting. Okay, and that will create a vector of strings, right? So that's what I want, and that's what I want to my letters to be. So my letters are that. Okay, makes sense? Okay, so that is sort of sets the baseline for my game. Now, the next thing I want, in this game, let me go back to this. I have my tree. I want this list of characters that the user will choose. Okay. So how do we do that? Any guesses? Basically, you just draw a line. Okay. So you draw a line in the draw function. You draw as many lines as there are characters, right? So I would probably do a loop of the number of characters. So let's write it. So I'll write it in my draw function. I will draw a loop. So for I in 1 to numbers, draw. Let's see. I have to draw a line, right? Now I have to draw a line so my screen, if you remember, is 600 by 500. So I'll draw my line at 450 at y-axis, right? And my x will change based on the character that it is. So the first character, x will be to the left. Second character, it will shift to the right. And so I will change my x-axis by the character ID. So maybe I'll try 50 times I, and then 450, and then 50 times I plus the width of my character should probably be maybe 30 or 40. So let's try 30. So 50 I plus 30 and then 450, right? So remember again, the coordinates are x1, y1 starting point, x2, y2 ending point, right? So 50i is my starting point in x, 450 is my starting point in y, 50i plus 30 is my ending point in x, and 450 is my ending point in y, which means that the line is horizontal and its width is 30. Okay. So, and then I want my line to be white. Okay. And then and here you go. Okay, now let's do this. Okay, So you see the lines are drawn in white, but you can see the lines are pretty thin. I probably want the lines to be a little thicker. And you would think that line probably should take a width, and that's, but it's actually simpler than that. I didn't want GameZero to have a very complex API. So what we will do to make a thinner line is draw just a second line in the next pixel. So what we'll do is take this and draw my y, increase my y by 1, right? And then I want the individual lines to be a little bigger. So instead of 30, I'll say 40. And that is the trial and error that gives you a good game, right? So now the lines are slightly bigger, and the lines themselves are also thicker. Okay, so that's my lines done. Now let's start taking user input, right? So the way you do user input in GameZero is there are a couple of ways. In this case, I want to take some action as soon as a key is pressed. So the way I do it is I will write a function called onKeyDown. And this takes a game object and a key object. So the game object is just some information about the game, and the key object is the key that is actually pressed, right? So the first thing I want to do is to take a key press. So I say, take the key. The key is actually, in some enumeration, I convert it into a string, and that gives me the actual key that is pressed. Okay. And then I say, I will say if key pressed in letters. So, if it is, you press some function key or the up arrow keys, and we just don't do anything. And if this is in letters, and if key pressed in word array, right? So this means that the key that you pressed is what you have chosen, right? Is what is the word that is there, the word that is selected. Okay. What do you want? So think about what you want if the key is, the user presses a key which is in the letter. What you want to do is you want to populate my answers array with the letters that has been selected. So word array is the word, the word itself in array form. There is a find all function in Julia, remember. So find all will return the positions in the word array that this key is in, right? So if so let's do this. So we have a word array. So let's see what our word is. Word is buzzard. Our word array is let's define word array. Okay, so we haven't defined word array yet. So let's define the word array actually. So word array is the word itself, but in array form, right? So we define the word array like this. Right? So word array is a vector of strings, right? And my answer, remember, is an empty array of spaces currently, right? So what I want to do is, let's say if I say my key pressed is A, right? If I say find all, that I probably need to increase my size here. That says 5 because if you remember my word is buzzard and A is in the 5th position, right? Now, if I say key pressed is Z, and I say that, it will give me a 2-element vector 3 and 4, right? So this function here, find all, will tell me whether my key that I have pressed is in my word array, right? And then what do we want to do? We want to actually store the result of this index, in my answers. So I say answer is, actually we said dot equals, because there can be multiple, and dot equals will allow you to assign multiple values into the array, is equal to key pressed. Okay? Make sense? Okay. So, let me, while we run it, I'll add a show here saying, found dollar key pressed in word. Okay. On this, and then I'm pressing keys. Okay. Let me show my REPL. Let me press keys A, E. Okay, and that gave me an error. Let's see what my error is. Answer not defined. Okay. So let's see. Answers. Okay. Answers. Okay. And let's say A, E, I, O. Yep. So O is there. So my code is now working. U is there in the word as well. B, Z. Okay. So that works, right? So I can find my word, and that is good. And right. So what do we do next? We want to display the text. If we actually find the word, then we will want to display the text. So the way I do it is in my draw, right? In my draw function, after I've drawn the lines, I say my text actor T. I have a text actor, which is my answer I, right? And I use the same font that I have, and in the position, in the ith position, right? So this actually should probably go inside. What happened to my num cards? Yeah, okay. So this should go inside the num cards array, right? So inside my num cards array, I draw the text, and then let me run this game. Okay, work. Okay. Because my screen is so small, it's getting very difficult to see the errors. So okay, where do I have answer? Okay. I have that. Okay, and now if I say A, E, I, O, U, right? And there you see my images is the images are showing. Make sense? Okay, so I think this is basically most of the game, right? Most of the game that actually interacts with the GameZero API. On top of this, all you need to do is get some score, right? So you need the ability to do a score. And so let's do that very quickly, because I think we are getting on with time. So let's see, we want score and state. So let's say we want score. We start with 15 because that's the number of lines we have. And so we know we count down from 15. The state of the game is playing. And then we move the state to 1 or lost as we go along. Okay? So we have a global called score. Now, this loop here, which is my drawing the tree, remember I'm currently just drawing the tree itself. I actually want to draw the tree as the score changes. So I will change this loop to something like this. Instead of saying I to 15, I say I to 15 minus score, and then I will draw just the number of lines that the score implies. Okay. I also want to draw a score itself on the screen. So let me, after my lines and my characters are drawn, in my draw function, I have text actor is, I create a text actor and I say draw SC. Okay. Make sense? So now then I have to update the score, right? So how do I update the score? When a key is pressed, that's when I update the score, right? So in my key press, if I say my on key down, this is my on key down, right? So if the key that is pressed is not in the word, I say else score equals score minus 1. And that's basically it. That's my game. Okay, so this word is what? 1, 2, 3, 4 words. I try some letters. I try A, and A is found. J, and that's a bug. Let's see. Score not defined. Okay, and that is because I have to say global score over here because I'm writing to score now in this function. So it's a global score, right? And now it's 5. As you can see, as I'm typing, if I'm typing the wrong letter, my tries are going down, and that's it, right? Tries are 0. When my tries are 0, I should say won or lose, right? So for that, I just on key down, I say if global state, if score is less than 1, state is lost. And if there is no more blank in answers, then my state is 1, right? And then in my draw function, I need to display some text. So I go back to my draw function and I type this code. Right? If state is 1, then I draw a text actor saying you won. If state is lost, you lost. So this code I will check in a minute, and you should be able to see it. But this pretty much, is my game. Okay. And history is complete, and I lost. Right? Play again. And A, E, I, O, U, E, C, Zodiac, yay, I won. Okay, so that's the game. Any questions on the game or anything else? I would be happy to answer at this point. If not, I think this is a good point to take another 5-minute break, and then we will come back. And once we come back, we will try to do a platformer where actually things move a little more, right? So we'll do a platformer from scratch, and that will hopefully show you how to do camera moves in a very simple way, right? So we'll try and get a simple Flappy Bird game going. And again, it can be less than 30 lines of code that will get a Flappy Bird game going. This Christmas game itself is, as you can see, about 15 lines of that is this data definition, and then on top it is 78 lines. So actually probably 50 lines of code that actually defines this Christmas game that we did. Okay, so hopefully that is useful and interesting. I will take a 5-minute break, and we will be back soon. We are back. Thanks for listening. Thanks for sticking around. This is probably the last section of the workshop, and then we'll be done. Okay, so the code that we just did in the last hour and a half is now on GitHub. I just checked it in. It's exactly the code that I wrote live with you, and that's on GitHub for you to refer to later if you're watching this later or trying your own games. The URL itself is on your screens. It's under my GitHub account and then GZ Workshop. So do take a look. The game that we did, the Christmas game that we did was, I thought, pretty fun, but it was static, right? Nothing much moving, some amount of interactivity, but things were quite static. What we want to do next is, show you some movement, and we will try to build a Flappy Bird-like game for that, again, in probably less than 100 lines of code. For the Christmas game itself, one of the things that you can try later is, have a way of restarting the game again. So right now, once the game is over, you have to close. You can have some key pressing start space to restart. You can do that. You can do different scoring schemes, score at different levels. You can do multiplayer. So all of those are things that you can enhance the Christmas game with. But let's move on to the Flappy Bird game. For the Flappy Bird game, we will want, again, we will start with an empty file. So we will let us go to my directory and create a new file called, what can we call it? Say flappy.jl. Okay. So flappy.jl. And we also need some images, right? Obviously, as you can imagine, we will need our images to show, the bird itself and the pipes that the bird flies through, right? If you haven't seen Flappy Bird before, then don't worry, we will build it ourselves very soon. So let me get a few images onto my images directory, and you can see what they look like, right? So I have my bird, which is the Flappy Bird bird. I have the bottom of the pipe and the bottom pipe and the top pipe. That's basically all I have, right? So let's start with just these three, and this is what will give us the movement. Okay, so flappy.jl, let's see. Let's start with height, 650, width equals 400. Okay, and let's have a function draw. And that's it. Let's also now have a function update, because we will update. We didn't need the update function before, but let's now use the update function here to actually change the positions as the frames go, right? So we will have an update function, and in the update function, you want to update where the bird is. So let's write update bird and update pipes, right? Because the birds and the pipes basically move independently. Okay? So, and these functions, we will start with empty functions, right? So we will say function update bird and function update pipes. So we'll go a bit quicker this time around. Right. Now, at the top of our file, we want the actors. So let's say bird1, which is our image. So let's start with bird0, right? Or should we use bird1? Let's use bird1. So let me get you bird1 first then. Let's copy bird1 here. So bird1 is similar, but slightly different. So let's say, right? And then the position of the bird is 25 to 100. That's where the bird starts, right? And then we want the pipes. So let's say the two pipes, pipe top, pipe bottom. Okay. So that's basically what we want. So let's try and run this game. Floppy.jl. Okay, and that gives me the game window, but no images because I haven't drawn anything, right? So let's go to draw, and let's just draw the three things that I have. Pipe top, pipe bottom, and bird. Let's run it. And there we are. We have the two pipes and the bird, right? And the two pipes are basically superimposed on each other, and the bird is somewhere in the middle because I gave my position as, remember, 120, 75 to 100 or something, right? So that's where my bird is, and these are my two pipes, right? So obviously these pipes, I don't want to be in this position. I want them to move at a certain speed. So let's say speed of the bird, speed of the pipe. So let's say my pipes move at a certain speed. So if the speed equals, let's start with 2, right? The speed of the pipes is 2, and then in my update pipes, I say the top left of the pipe moves at the speed. Let's write it simpler. Pipe top dot left speed, and pipe bottom left is equal to pipe bottom dot left plus speed. Okay, and let's see what happens here. And the pipes are moving that way. Now I don't want the pipes to move that way. So my pipes are moving that way. I don't know. which way? I want them to move the other way around, right? I want them to come towards the bird. So I change the plus to a minus, which is easy. So my pipes are now moving in the correct position, correct direction, but of course their positions are not correct, right? So how do we start the pipes? Let's see. Let's start the pipes in a different way. We want the gap between the pipe to be a certain value. So let's say pipe gap y equals, 50, right? And then we say pipe top dot left equals let's do this. Right? And we say bottom dot bottom left equals the same thing. Right? And we have another constant called gap, which is 100. So this is the gap between the pillars and the bird as it starts, and the pipe gap y is the gap between the top and the bottom. And these two these two lines basically initialize my pipe at a certain distance on the right of the screen, right? So let's see what this does. Okay, so my pipe gap y should probably be around 250, let's say. Yep. And my pipe top, I want the bottom left as the position, but my bottom pipe, I want the top left as the position. So this is wrong, right? Because I want the bottom of the bottom pipe is outside the screen, the top of the top pipe is outside the screen. Does that make sense? And there we go, right? And this is how you basically move your camera. You can basically just fake it by moving your background. Make sense? We can watch it again. I might have to restart my Julia REPL. It's not happy about something. Oh, there we are. Exit. something is killing my machine. Now let me see if I can find out what. It's just streaming out. The streaming is killing my machine. Oh well, let's carry on. Okay, so I just restarted my Julia REPL and just getting GameZero compiled again, and then we can run game, right? So now, if I run this, you will see that, yeah, it just moves and moves out, right? So we need now some check where we check that if the pipes have reached the end of the screen, we restart again, right? So let's do that. This pipe function, this I can put this into a function called set pipes, right? Instead of being at the top, because I have to keep doing it over and over again, I put this to a function. Okay, so this is now in a function called reset pipes. And then in my update pipe function, I have to say that if so let's go to my update pipes. I say if pipe top dot right greater than 0, less than 0, right? If pipe top dot, if the right side of the pipe is beyond the left edge of the screen, then you reset pipes. And what reset pipes does is, remember, it will just initialize the pipe at the right of the screen, which is the width, right? So my width is 400, width is 400. And so the bottom, the left of my pipe will be at the width. Right? So there goes my pipe. And yeah, there's probably a bit of a bug in GameZero where, you know, the right is not the edge, but it's like finishing somewhere else. But you see how, you know, it's coming through and then going back. Yeah. Now, the next thing that we need to do is move the bird. So let's try and move the bird. So to move the bird, we need a velocity. So let's write that. We say bird y, bird velocity y, which is the y direction of the velocity of the bird. Let's say 0, right? And then we need a constant for gravity. Let's say how fast gravity is, which is the velocity of the bird will increase over time, right? We want the velocity to be increasing. We want the bird to be accelerating, right? And so we need a gravity constant. So let's say my gravity is let's say 0.2 to begin with, right? Higher your gravity, the faster it accelerates. Okay. And then when we press a key, we want the bird to actually move up, you know, to interact, to go against gravity. And so we will need a flap strength. So let's say flap strength. This should be flap strength should be maybe something like 5, right? because that goes, it goes up against gravity, and then again gravity starts hitting it and taking it down. So let's do an update bird. So in my update bird, that's where my gravity happens. I say I want to change my velocity, right? And let's say my current velocity is variable y, and then I say my bird velocity is velocity plus gravity. Okay. Then I say my bird dot y is what changes, right? I actually want to average the previous velocity and the new velocity, because that's how you basically you're changing the velocity by right? And that's you're basically doing finite different thing here, right? And then I actually position is an integer, so I need to convert this division into an integer, right? And my bird.x doesn't change, so I say bird.x is the same. Right? And you see my bird is falling. So I want my gravity to probably be slightly higher. I want my gravity to be that's my gravity. Let's say 0.5 or 0.4, and you see it's falling faster, right? And I can make it fall even faster by changing the initial velocity. My initial velocity is 0, so let me change my initial velocity to be 0.2 and gravity to be 0.3. Let's try that. Right. It's still too slow. My gravity should be, yeah, that's fine. If you want faster, if you are an expert player, you increase your gravity, and then it'll start falling much quicker. And as you see, as it comes down, it's getting faster and faster, right? The next thing that we want to do is we want to see if the bird collides with the pipes, right? So the way we do collision is, again, this is in the update function of the bird, right? So let's say if collide bird so collide is a function in GameZero, and that tells you whether two actors have collided or not, right? And then you can write something like if it collides with bottom, right? And then we will say we want to store the state. We will say bird head is true. And if bird is dead, we will say bird, we will change its image. Bird.image equals okay. And let's see, do we have this image? We don't have the image for the bird dead. Let's get that image here. And that is the dead image, which is grayscale. So that shows you that the bird is dead. Okay, so when the bird collides with either the top pipe or the bottom type, we stored the state. Now we need a variable for the state. So let's say global bird dead, and we initialize it as bird dead equals false. Okay. Okay, this starts with there's a bug. Okay, what's the bug? Bird dead is initialized to be false, and bird dead is true. Okay. Okay, because it so I did not reset pipes before I start drawing. Let's do that. And okay, that has to go at the bottom below the function definition. So reset pipes initializes my pipe, so I need to call it at the beginning as well of the game. And there you see. And then when it collides, you will see the bird is changed to dead. Right? So now what do we want? We've done the collision. We've done the bird dying, and then now we want to say that if somebody presses a key, the bird basically flaps, right? So the way it flaps is that it changes its velocity from going down to going up, right? The code looks like something like this. We do a function called onKeyDown, which takes a game. We don't actually want the key because we will do it on any key. We have the global bird velocity. Remember, we used it before. And so if the bird is not dead and you press a key, then the bird will flap, right? It'll move up, right? So let's do that. And see what happened? Now the bird is starting from the top. I don't want the bird to start from the top. Let's say the bird starts from x of let's do this. Bird.y is that, and bird.x is always 75. Okay, and the y velocity actually, so we create the velocity, this should be plus equals because we want to add to the position. Right? So let's do that. Okay. So you see, so that's too fast. So let's set it back to 0. Let's set our gravity back to 3. And there you go. And that's the game. We need some checks on whether the bird is dead or not. But this I'm pressing space, that makes the bird jump. Make it jump too much, it touches the. And if we don't make it jump, it goes. So I think the only other change I will do is when I reset. Remember, I reset pipes and I said the pipe gap is y is 250. So the gap between the two pipes was always constant. Let me change it to a random value, and which is sort of slightly more than 200, but and that's Flappy Bird. Okay, so hopefully you see how that works. Okay, so let's take a few questions that have come up. A collision example with 200 agents, that should be fine. The collisions are actually quite quick, the computation. We just store the positions and check whether the positions overlap. So with 200 agents, the only thing with 200 agents would be that you would create an SDL surface for every agent, because the actual image is stored in a surface that is blitted onto the screen, and so that's so that the amount of memory that it takes to store the surface is the only consideration. But you can just create an array of agents and create collisions, and that will that should work pretty well. You can do basic simulations, so I could probably end by showing you some of the examples that exist. So let's say example. So these are all in the GameZero examples repo. So there is something called Pandemic Sim. I forget what it's called. Let's see. Cheesy examples. Pandemic. Sim.jl. Hopefully this works. We haven't tested it for a while. Yeah, okay. Okay, so that's simulating a pandemic where you have the red infected patient, and then when they touch or they collide, when they overlap, they will infect. So now you can see the red is actually in the corner of the screen, so that's good. They are not infecting, but yeah, you can do things like this using GameZero quite easily. This code is based on a workshop that David Sanders did last JuliaCon, where he talked about the actual simulation, the raw simulation code, and then we converted it into a GameZero example. So you can see, there we started with one patient, and now we have 3 patients, and hopefully this time, we will infect a little more. One patient turned cured, so that's the green. And so when the green patient overlaps, then they don't infect anybody. But now we have a cluster of patients on the bottom right of the screen, right? So yeah, you can do things like this. absolutely with GameZero. And this is, these are not actors, these are just circles, and we store the coordinates separately. So we don't pay the cost of the surface itself. But you could have done this with actors, in pretty much the same way. The code is pretty self-explanatory, right? So this is one example that you may want to see. The other one is there is a, and this one should work, which is breakout. So breakout.jl. So this is a breakout game. So again, so this is keeping track of the bat and the ball and all the bricks. And the individual bricks are modeled as in a data structure. It's a array, I think. And there I lost it. It gets faster and faster. Oops. Right. Okay. So that should be interesting. Before we end, the last thing I wanted to show are possibly places where you can find more information. So let me get a browser window on this. So let me refresh this. The code that we did in the previous session is here. I will upload the Flappy code as well in a minute. But what you also want is GameZero.jl, which is the package itself. Let me try and increase the size of the font. So this is GameZero.jl. And this is where you can see the code. There's a link to the documentation. And so the documentation gives you sort of the assets, how to use actors, moving objects, so the entire documentation. And in GameZero itself, if you go to GameZero, the source code, actually we should have them here as well. Yeah, so the examples are also part of the documentation. So if you go to click on the examples, the examples are, the code is shown. So you can just copy paste this code, and there is some comments that tell you what the code is done. There are some basic games which just show you the APIs. There is the breakout game, which is what we showed just a minute ago. There's the pandemic sim game. There's a tic-tac-toe game. There's also a full Flappy Bird game. Yeah. So all of these games are there in the documentation. If you want the source code for the games, you can just cut paste from the documentation itself, or you can go back to the source. And so this is GameZero. So actually not in source, in examples, all the source code is here, right? And the other place you can go to is if you go to squid thinker / easy examples. All the examples that are there in the documentation, the actual code is here. So if you go to pandemic sim, there is a screenshot and there is the source. Right? So this is the source. We create a struct of humans, we create an array of humans, and then we just update based on the location and their state. Yeah, and based on the state, we can create, right? So yeah, so this is GameZero. You can create actors, you can store their positions, you can store random state in the actors, and you can then draw them, you can update them, and that basically gives you the game. I don't think there are any more questions. So is there a way to move objects relative to time? That's an interesting question. So the update, we showed you a basic update function, but if you go to the full update function, let me go to an example. The update function, one of the optional arguments it takes is a time step. So you can take a dt, which is a time step between frames, and the system will call your update function with the time step that it used for the frames, right? And that will allow you to change your state based on the time spent between two frames. So if if your frames are long, you can then move your things faster. If your frames are short, you move your things slow. You move your actors slower, right? So the update function takes an optional time step argument, and when that update function is called by the system, then that's where you can change your behavior based on based on real time, right? Hopefully that answers your question. There's a question about making physics-based simulation. I showed you how to do that. Gameplay be captured as a video, not directly. I have used previously, things like Windows built-in video capture, and that captures it. You can use Camtasia. I have used OBS to capture videos, and so you can use some external tool to capture this simulation running. And that's pretty standard, right? So any third-party video capture tool should be able to capture the video, right? So hopefully that answers all the questions on Pigeonhole. I'm not sure if I have missed any questions on YouTube because it scrolls up quite quickly. If there are any other questions, find us on Slack, on the Julia Lang Slack. There is a game dev channel. That's where many of us hang out. And so, you can find us there. So all that remains to say is thank you all for listening. I appreciate the time. Hopefully this has been interesting for many of you. I hope to see more games. If you create a game, please do a PR to the examples repo. We want more and more examples that people can see. So, submit your games to the example repo. That will be great. So that's basically it. Thank you for listening and hope you enjoy the rest of JuliaCon. Thank you. Bye-bye.